I'm so excited to be here with everyone. Thanks for tuning in. I'll start with a little bit of an introduction for myself. I'm currently a product manager at Altair. I'm actually building up my own MLOps team. We're building on our Altair data analytics platform. So some of the things I'll be talking to you about today is something I'm using to build into our product directly. And before this, my role was as a data science manager at Altair. So I led a team of 5 data scientists there. And before that, I was actually also a product manager at a company called Points for integrating machine learning into Points' product. And I was also a data scientist for a few years before that. So I've been waffling back and forth between product and data science, but specifically machine learning based product management. So what I'll talk to you about today is getting your first machine learning model into production. So some examples and considerations to think about. So the agenda for today we'll talk about some of the practical aspects of starting this work on getting machine learning models in production and figuring out from the very beginning, like what are some of those important business KPIs that you're looking for when you're trying to build up these machine learning models, starting with some prototyping. I'll talk about deployment methods, building up the pipelines that suit the business needs, and also bringing it back with closing the feedback loop. So during this presentation, I'll talk about the first 3 phases of getting your machine learning models into production. So from phase 0, which is first figuring out if it's the right time for you to build a machine learning system. So what I mean by this is sometimes you might have business rules that are good enough and the business is happy with those, and you need to figure out if you can improve on those or if there are other low-hanging fruit that you should be going for when building up machine learning models. So part of that is selecting the KPIs that you want to affect your business outcome, to get buy-in from the business. Are you trying to address areas of the business to bring in new business? So for example, if you're e-commerce, are you looking at increasing conversion on your site or increasing basket sizes? Are you looking to save money perhaps with detecting and preventing fraud or reducing risk in a credit portfolio? Or maybe you're looking on optimizing different parts of your business and reducing the cost of doing business. So identifying those KPIs is one of the first important steps to actually getting buy-in for the business and getting the right KPIs that you want to target when you actually assess your machine learning models. The next step is actually going into prototyping your first machine learning model to show value. So you get that first pass of the data, you create your initial model, and you want to map the outputs of the model to the actual KPIs that you're interested in that are relevant to your business. And also you want to check your results with business subject matter experts. So I'll give you some examples on what that might mean. But for example, if you have a heavily regulated industry, you want to make sure that you have an explainable model that you can show why you arrived at certain decisions, and also that these decisions are actually impacting business. Next, we'll talk about the next phase, which is building and deploying that first pipeline. So first, you need to actually determine what that pipeline looks like. You need to think about where the data lives, the quality of the data, where that model is deployed. So is it an e-commerce website where you need to do real-time scoring? Is it perhaps a database that needs to be batch updated with a certain outcome? What is all the infrastructure that's needed for that? What are all the teams that are involved? Do you need to involve IT and DevOps and data engineers and machine learning engineers? So building up that initial plan and infrastructure is very, very important to making sure that you can go that last mile and you can actually get your model into production. So I'll talk a little bit about different deployment methods that are simple, for example, batch up to more complex real-time scoring deployment. So we can start out as a very simple example that is batch, where you have just a data science team or perhaps even a single data scientist. And let's take a use case of generating a prediction for which customers are likely to buy a certain product. So you might build up your model in a simple Jupyter notebook, create a list of predictions as a simple CSV file, and you send that CSV file to a marketing team that then, sets up their emailing system and sends a bunch of emails with their offers. Customers click on those offers. Perhaps they buy the product, perhaps they don't. But there's no feedback loop in this case. There's a lot of room for error, but it's really quick, and not a lot of scaffolding and infrastructure needs to be built. If we go a little bit further in terms of complexity and increasing that scaffolding for getting something deployed, let's say, again, we have our data science team that's building the models and generating these predictions, but we might have an engineering team that maintains a database, a production database. And that production database can be accessed by other departments, such, let's say, the marketing team can go in and get the product offers that the data science team has generated, but perhaps this database is also linked to the application. So let's say we have a customer logging in to an application, and that talks in real time with this database of offers, and then the customer can get that offer in real time. So perhaps, it's a batch generated offer, but accessed in real time. So increasing in complexity and also generating the potential to have a feedback loop. So capturing the actual outcome from the application and storing that into the historical data that can be reused to train a model. And then we have, for example, a real-time production setup where we have a data science team that creates a model, and then there's a handoff to machine learning engineers and software engineers that maintain a system that productionize these models. So they take the models, they might refactor them, they might maintain the data pipelines, and they have this model, they make it available to, let's say, be scored in real time, and then the application talks to that model, generates the offers, let's say, and the application returns all of the predictions as well as the outcomes back to a historical database. So these are some examples of how you could think about setting up deploying of a model. And what I want to show you now is a real example of something I've done in the past. This is a project from Points where we worked on real-time hotel ordering. So just to set the background, we had hotel popularity is what we used to rank hotels on a search page. So we wanted the most popular hotels to show up at the top because people want to see the best possible hotels and they don't want to scroll a lot. And we thought with the subject matter experts that we can do better than a hotel popularity, and we could build our own model to essentially have better predictions on how likely a hotel is going to be booked, and then have the best rated hotels most likely to be booked show at the top of the search. So we began by gathering the data and creating features that were available from that data, and using a Jupyter notebook with an environment maintained in Docker. With all of the data science tools, and starting to build up those models at the very beginning is a very simple decision tree model built in scikit-learn that was prototyped and was presented to subject matter experts to make sure that the model made sense from their perspective, as well as that it shows some improvement in the KPIs that would be interested in. We built a system in GitLab with GitLab pipelines to take this initial Jupyter Notebook code and put it into Python code that would go into GitLab. This was evaluated by software engineers, and they looked at the code, they refactored the code. We built in approvals for that code to make sure that any changes that were made sense. Within the GitLab pipeline, as each individual part of the pipeline was run, it would create logs and artifacts. And at the very end, we got an artifact for a model. In this case, we used PMML models, which stand for Predictive Model Markup Language, which is basically language agnostic way to represent a model. Because I was working in Jupyter and the application itself was built in Ruby. Once we're happy with the model, we have the artifacts that we want to deploy. We integrated with a Jira process where we actually followed the software release cycle for the application itself, and then we linked it back to the artifacts from GitLab. Once we were part of an official release, the model would actually be uploaded into a staging environment, and we would have some testing done on it to make sure that the model was generating the predictions that we were expecting it to generate. Again, it was a very simple model, so we can easily track that. And then just to make sure we had the right model in production, especially when we got to multiple models being deployed at the same time for multi-arm bandit type of testing, we needed to double check we had all of the right things in place. So once the model was in staging and it passed our initial testing, we made it available in production. But in production didn't mean it was on by default. For that, we actually built an A/B testing framework. Initially, we just had simple ABN testing with static traffic splits, but then later we developed multi-arm bandit testing, where we could put multiple models in production at the same time and adjust the amount of traffic dynamically to have the most traffic going to the best model at one time. And then we built in that feedback loop where we have the model and the outcome so we could calculate our business KPIs and we could store that data. And when we had new data and felt like the model maybe was going stale and one model was good or one model was doing poorly, we would start the cycle all over again. So rebuild the model, check it with subject matter experts, commit the changes, get the artifacts, working it with engineering to get into a release cycle. So this is a real example of how we actually get a model in production. And it's a lot of infrastructure to build to get to that last mile to be able to have a model that's actually making a difference. So next, I'll just talk about a little bit about the last phase I'll touch on today, which is feature engineering, launching and iterating new features into the pipeline. So some of the things I want to talk about is this is a very often referenced image with all of the things that you have to consider when you're looking at launching machine learning. So whether it's maintaining features, verifying data, any kind of process management tools. And I'm going to talk a little bit about monitoring. I won't talk about the other aspects, but those are several other talks. So some considerations. So obviously the features that you use in model training have to be available for model scoring in exactly the same way. And what I've seen with many organizations and also this particular project is what was built by data scientists has to be sometimes rebuilt by data engineers in a different system. So you have to make sure that those calculations are done exactly the same way. And you also have to think about which features are you calculating in batch or real time, and especially if your process is real time, what is the response time needed, and can you calculate it in real time, or do you need to do it in batch and then access it in real time? And also have a process in place for creating new features. So I have a funny story where we had a specific feature that we noticed wasn't behaving the way we thought, and a subject matter expert suggested we change the way how we calculate that feature. So an engineer said, great, I'll go ahead and change that calculation. I said, no. We have to create a brand new feature, give it a different name, because if you just, retroactively change how the feature is calculated, all of my models are going to become wrong or invalidated in some way. Other considerations around process for deployment. There are many teams that are involved in this type of process. So you have to figure out what are the handoffs between teams, what are sign-offs, approvals, any process tools like Jira. How do you track changes made to data? And then which teams are responsible for which part of the pipeline? So if a part of the pipeline breaks, which it will happen, who is responsible for fixing it? What is their lead time? And how do you deal with having certain parts of the pipeline going down? Do you have any rollback procedures, et cetera? Other things to consider are monitoring and reporting. So I talked about an A/B testing framework that was built. So we had a dashboard to track the performance of the models that were out in production. We tracked the KPIs and model performance. And we, very importantly, wanted to link the business part of that performance. So we want people to book hotels. Well, we're looking at, conversion. We're looking at, how many people searching versus booking, looking at that entire the entire journey of the customer through our site. And A/B testing, again, we want also built in ways to test for significance between those KPIs. So if we're looking at conversion, 10% versus 15%, well, is this 15% significantly higher than the 10%? And do we have enough data to be able to say that? And that was the last point. Just wanted to bring it back. So right now, I'm taking all of this and building up an MLOps roadmap for my team at Altair, and we think especially collaboration between data scientists, data engineers, and machine learning engineers is crucial to get that end-to-end deployment within for machine learning. All right, so that's essentially what I had for a real example and some considerations for you to actually think about, what do you want to do in terms of getting machine learning into production? So I'll take some questions now. And thank you, Adam.
Thank you. Yeah, that was really insightful talk. It seems you've had a lot of success and doing a lot at Altair. They're lucky to have you from the sound of things. So we have a couple of questions. The first question is from Solange. I think I may have pronounced that right. Are you using Docker only for prototyping or sometimes also in production?
That's a great question. So in that particular project, we were using Docker just for prototyping. It was a way for us to maintain track or to maintain package dependencies, version dependencies, things like that for prototyping. Because we were deploying in a completely different environment with Ruby, we weren't actually using Docker there. Although for what I would recommend that if you can use Docker throughout and perhaps use Kubernetes for orchestration and deploying models, that would be ideal to be able to keep consistency of your environment throughout.
Thank you very much. That's great question and answer there. We've got another one again from Wilco. He loves it. Good to see you again, mate. If you look at the pipeline, which parts do you consider typically the best candidates to use off the shelf versus building your own, in particular, as you have to integrate all the components end to end?
That's a great question, and this is something I'm looking into right now as part of my current role. A lot of what you'll have to build yourself is all of the data prep pipelines. So this will obviously depend on the type of data you have, the sources, how hard it is to get those sources. In the project I talked about, we had, S3 data was that was in files that were dumped on a nightly basis in S3, and then we had to process all of those files. There are gigs and gigs of data that were processed on a daily basis to generate the features that we would use in model training. So sometimes there are off-the-shelf open source and paid tools. For example, we're using GitLab pipelines to manage our pipelines, but we had Python scripts, which is open source. There are tools like MLflow that will manage things like model repositories and maintaining or keeping track of different artifacts like model artifacts, as well as model performance and model hyperparameters that you used to build the model. So there's a lot of bits and pieces that are either open source, paid, or you have to build your own depending on your business. The best candidates for off the shelf, I would say things like maybe using things like Docker and Kubernetes, using ways to source control like GitLab or GitHub. I wouldn't go building some of that, from scratch.
And the last question we have was from Ashira. Does all the experimentational model from the Jupyter Notebook make it into production? If not, how do you determine the model that goes into production?
That's a great question as well. So not all experimentation makes it to production. So we'll have, in that project, we had different gates that the model had to pass. One is it had to have decent performance, but it also had to make sense to the subject matter experts. So we always had sort of like a little committee that would review the model and the model behavior, and then we would that would pass it into production. And then we wouldn't actually use Jupyter Notebooks. We would convert these to plain Python scripts that were put into GitLab.